All right, here comes the packet lesson, 4.2. Again, the title got cut off. It was on page 125. But here we are, and it's got a little description of exponential growth, exponential decay. Please watch my pre-lesson to get an understanding of what's going on here. But now we're going to get into some definitions. So look, let A and B be real number constants. What does that mean? No variables. Okay, so what we're going to do first of all is we're going to scan all of this and look for our A and B that aren't constants. They are variables because this says which of these are exponential functions. Well, the first thing to cancel them is if A and B are variables. So this one's a little tricky because that's actually 1 times 3 to the x. So here's my A, here's my B. So are both of these real number constants? Yes. So we'd say yes, this is a function. And then it says state the initial value. By the way, the initial value is A and the base is B. So A would equal 1, B would equal 3. Now look at this one. This is this is the same thing as 6 times x to the negative 4 power. What's the problem here? The problem is my A and my B, according to this definition, must be real number constants, no variables. So guess what? That's a no. How about this one? Well, if we kept reading, just get a little bit more precise, I can see in this one, an exponential function in x is a function that can be written in the form blah, blah, blah. We talked about that a lot in the pre-lesson, where A is a non-zero. That shouldn't be a problem. B is greater than 0. That means positive. And B does not equal 1. So look at, is this a real number constant? Yep. Is this, by the way, this is my A, this is my B. Is this non-zero? Yes. Is it greater than 0? Yes. And neither of them are variables, so we say yes. It's an exponential function. What's A? A is -2, and then B is 1.5. And then we go here. We can see that A is 7, B is 2, and that's a yes. And then we look here, and we say, wait a minute, look at that guy, pi. How'd he sneak in there? Remember, this has to be a variable x. See, these are variables. 3.14 would be considered a constant, so that is not an exponential function. And then here we go, we got an x here, which is no problem, but we have an x here, which is a problem, because this is actually 1 times x to the 3x. This is not an issue. This is not an issue. This is an issue. You see, that's my A, that's my B. We cannot have a variable for our A or our B. Those need to be constants, so that would be a no. Okay? Now let's go on to this next one. How significant is this? Not too significant. You'll see as we continue. This says compute the exact value. So that just means plug in, let x be 0, and plug it in. So I go 6 times 3 to the 0 power. Well, anything to the 0 power is 1. So that's 6 times 1, which is just 6. See, I'm done with that one. Now we got to put in -2. So 6 times 3 to the -2. Well, that's just the same thing as 6 over 1, that's this, times 1/9. Cross reduce, swoosh, 2/3. Now we're going to put 1/2 in for there. So I go 6 times 3 to the 1/2 power. Now this gets a little tricky. Don't know if you remember this from Algebra 2, or wait a minute. Yeah, the previous lesson we talked a lot about it. So this should not be tricky. But this is the same thing as 6 square root of 3. Now there's nothing wrong with this, but I think pre-calculus / algebra wants you to understand by now that anything to the 1/2 power is the same thing as the square root. So it's just a little exercise, a little extra practice. Now this gets interesting. This says determine a formula. Now I want to be a little bit more specific. The formulas we're talking about is either this guy, which is exponential growth, or this guy, which is exponential decay. So I'm going to write that right here because they're both the same. F of x equals a times b to the x. And I don't want you to be confused because this says g of x and h of x. Don't worry about those so much. They're interchangeable with this, okay? So how do we find this? Well, what I said in the pre-lesson was you can find out what a is by looking at what does a equal if x equals 0. So remember, if you put x equals 0 in here, it turns all of this into 1. So a sneaky way of doing that is find out where your x is 0. See, I'm concentrating on g of x right now. I'll get to h of x, which is this column, in a minute. So this is one math problem, and this is one math problem. So I'm concentrating if x equals 0, notice how we get g of x equals 4. That's a sneaky way of letting you know that a equals 4. And so we go, okay, we're going to fill that spot in. So we're going to get f, well, I should say g, sorry about that, g of x equals 4 times b to the x. So what we need to do is find out what b is. Here's how you do it. See, there's a multiplying factor from here to here, here to here, here to here, here to here that's consistent. And I don't really concentrate on the fractions too much. I go for the obvious. What times 4 is 12? 3. Does that remain consistent? Yes. 12 times 3 is 36. So that would turn it into g of x equals 4 times 3 to the x. So it's a two-step process. Find out what a is by looking at what the equation equals when x is 0. That's pretty easy because it gives it to you. So let's just go right to it. H of x equals, see, now we're looking at this. If x is 0, h of x is 8. That's telling you a equals 8. So I'm going to go 8 times b to the x. Now this one's a little more difficult because notice this one's pretty self-explanatory. I'm going from lower to higher, and I notice 4 times 3 is 12. 12 times 3 is 36. But wait a minute, from here to here, there's no multiplication. Yes, there is. From here to here, there's no multiplication. Yes, there is. See, from here to here, it jumps out at me. We're going to multiply by 1/4. By the way, what if I multiply this by 1/4? Will I get 2? Yes. So you see, it's multiplication, but it's a fraction. So that means h of x equals 8 times 1/4 to the x. Remember, these need to be constants, and by definition, b is greater than 0, but they can be this can be a fraction, okay? All right. Now, this example 9, describe how to transform the graph of f into the graph of g, is going to go to the next page. So let's go to the next page. And this goes back to your good old graphing days. So they're not letting off the gas here with graphing. They want you guys to really understand it inside and out. So they're saying, if this is my graph, which by the way, you don't need to know this, but if I put 0 in right there, this is the same thing as f of x equals 1 times 3 to the x. You see that right there? So if I put x is 0 in there, right here, that'd make this a 1. 1 times 1 is 1. So 0, 1 would be my intercept. And because this is this is my a, this is my b, and this is a whole number, it's going to be exponential growth. Now, I don't know exactly how fast it's going to go up, but generally speaking, there's exponential growth. This is saying, hey, what would this do to that basic graph? Well, the rules are the same as parabolas. For example, if I had f of x equals x squared, it'd be like this. But if I want g of x equals x minus 2 squared, that would move it right 2, if you've been listening at all. So what does x plus 2 do? Moves this whole thing left 2 units. You don't need to graph it. I just showed this to kind of give you an idea what's up, but you're also going to need to understand it for down here, so I'm kind of getting ahead of the game here. All right, so there's A. B is going to be a little trickier. So if you notice, we got a negative right there attached to our x. Now, if you were listening, and this is a tricky one, but I said, okay, well, let's go h of x equals negative x minus 2 squared. I'm talking about the parabola now. This right here would flip it over the y, but because this is negative, see, if that negative wasn't there, I'd say, that's to the right 2. But because that negative is there, that's going to be left 2. And again, please go to Desmos if you don't believe this, okay? But that negative is going to do two things. It's going to take this graph, it's going to flip it over the y-axis, but it's also going to take that negative and say, now it's going to go left 1 instead of right 1 because of that negative. What does that 2 do? That's my A. Well, what does it do? Well, it's going to vertically stretch it by 2. What does that negative do? Flips it over the y-axis. All right. What does this negative do? That flips it over the x-axis. What does that negative do? That's going to flip it over the y-axis. And then this right here, the 2, is going to cause a horizontal shrink factor of 2. Again, that's a Desmos special if you want to check that out. All right, what does that 3 do? That's a vertical stretch factor of 3. What does that 2 do? That's a horizontal shrink by 2. And then you're just going to go up 1. All right, so this one, grand finale. So I've already graphed this kind of up top, kind of goes like this, and it's an exponential growth. This is just saying, go ahead and do it, sketch it. Well, that's going to be left 2. So I go 1, 2, and it's kind of just like this. Left 2. Is my drawing perfect? No. But I'm demonstrating I know it's left 2. This guy, believe it or not much different than that guy. And I'm not going to get too worried about that. But there's the original. What would that do? Well, that'd be over the y-axis. So this would flip over to this side. This would flip over to the other side. And that finishes up section 4.2, packet lesson.